You have, he also did bees. That would be the next talk, so let me move on. This is an outline, quick Mendel scientific polymath. Polymath has nothing to do with mathematics. It has to do with, he was a jack of all trades, is what you would translate that to in common English. He did a lot of different things. The astronomy part is limited because most of the stuff maybe was burned. We did observe sunspots. We didn't do anything at night with stars. His major work will be meteorology, where he had 9 of his 12 publications were on that. And we'll talk about that. And his claim to fame was actually this meteorology was a tornado observation that happened later in its place. And as a detail, it's the first detailed account, scientific account of a tornado, 30, 40 years before anybody else. And it wasn't recognized until, it was recognized in his time, it made the newspapers, but it wasn't recognized until the 1980s, 1990s. People didn't read it. The book is there. It's a book on tornadoes. It's the Broome tornado. And we brought it on the rare books. And there's a guard here. It's worth about $1 million. So I want to thank Frank Maloney over there, who maybe will be sorry I recommended me. Father Ellis, Michelle Travolti. I'm using a lot of photographs that Father Ellis took. Father Ellis aren't so great. He's not a good photographer. Well, the light levels were low. I was very happy to have for technical support with the Czech language. Peter Hermanitz is from Prague, and Scott Engel helped with some of the videos. And also, a lot of the material comes from the Bern Museum, and the director is here, and Chris is in the audience, is going to give a talk later. So this is how it works then. This is beyond peas, I put that in green. And so he's known for his work on inheritance, and that's what the first symposium was about, and genetics. Genetics didn't exist at his time, it's a word that came along later on. And the studies of peas. It's polymath, means he was interested in a wide variety of things. He worked at, he went when he was in the priesthood, or going into the priesthood, he went to Austrian University, Vienna, and took what would be called a comprehensive science course here. He took zoology and physics and things like that, chemistry. So he had like a little bit of these sciences. One of his teachers was Christian Doppler, who's known for the Doppler effect. And he got a grade of 10. I have his report card. I would not like mine to be shown there. Zoology, but the first one is Doppler, very well known at that time as a kind of a rigorous physicist. So maybe what happened is that he learned his scientific method approach, which is what he uses from his education of a variety of science courses that he took, physics courses, math courses that he took there. So he applies what's called scientific method, observing things, making a hypothesis and a thesis, and kept meticulous records. And he had wonderful handwriting. His handwriting is fabulous. You can always tell his handwriting because of how neat it is compared to mine. And he did all this while being a prelate, being a priest and abbot at the observatory at St. Thomas of Villanova there, and an increasingly heavy and difficult workload. He carried out a lot of experiments. So this is the picture you usually see. So this is Gregor Mendel, at his birth, 1822 1884. On genetics, his botanist, hybridization, and heredity is what he was working on. You usually see him holding that little uncomfortably heat. And then down here I put in what the polymath was, because I had to look it up too. I had something to do with mathematics, but there's nothing to do with mathematics. Well, what I did, because he was a polymath, I found pictures that weren't published previously. There's Mendel as a meteorologist holding a barometer. I had to hunt really deep in the archives. This guy was more and more puzzled. Yes. And Mendel covered, there's a giant bee. Doesn't look like a bee. Covered as a beekeeper, as apiology. And that's going to be the next talk. Gina's going to talk about bees. So the astronomy part is what he was interested in, because his schedule was so tight that he really couldn't observe at night. So he was a solar, he did solar observations. Mainly motivated, all his work was kind of connected with his upbringings as a farmer and agriculture. So a lot of the things that you see here are all connected with that. Even the genetics and botany was trying to find things, weather, and how it affects crops. It was all connected with that. And he then observed sunspots, and most of the data is lost. I only found one page, and I confirmed that those other pages probably afterwards was put outside and thrown away. This is a sunspot. This is the size of the Earth. These are huge magnetic storms on the sun. So this I found at the museum. This is so his training was rather shallow because he based it on popular astronomy books, which is shown here, but it has annotations about the sun in it. So what he did there is he has a telescope, which is over here, called a Rashi telescope. It's at the museum. The mirror is missing, but that's the telescope he probably used. And what he did, you can never look at a telescope with the sun because you will never see anything else. It will blind you. So you project the image of the sun. See Mendel wearing sneakers? Project the image of the sun onto a paper or this, and then you make little circles. You then use a pencil and sketch those in. That's what he did. And unfortunately, if there's more of this, I couldn't find it. And so what it ends up with, this is the telescope he used. I even found the purchase of this called a Brachy telescope. And it's unusual design. The mirror is here. The light comes in along here, reflects off this mirror to that mirror, and then back through the eyepiece. And this avoids blocking the star. Most of the time what you do is you put a hole on this mirror. But it blocks some of the light. So it's a nice kind of telescope for doing solar observations. This is his sketch. It's just kind of, there's better ones I think, but what he's doing here is sketching sunspots. So each day, if it's clear, he would sketch these, and you would see the sun rotate, which you show in a modern picture. This is sunspots moving across in about a week. And this is giving you the scale of what these things are. This is the Earth compared to a typical sunspot. So these are huge magnetic storms. They're dark because they block the radiation coming out from the sun. So I couldn't find much more than this. But what I did do is I did use this data here to determine sunspot number. So this sunspot observations he thought were related to, and they may be related to weather and climate. And so this is a detail. This is sunspot numbers from the 1600s. This is the observations of Galileo, first telescope. And this is his observations of sunspots. He didn't know what they were. And this is called sunspot. This is the data up to 2000. The sun has an 11-year cycle where the spots become very large, the sun becomes active, there's flares, and it actually gets slightly brighter. So this is one of the things I put this up for, is that this is one of the things that shows up when you deal with climate change. So again, Mendel had had nothing to do with this. I'm just plotting why sunspots are important. But in this time here, called the Maunder minimum, the Earth was cold. It's about a degree colder than today. And a lot of people associate that little ice age with the sun, because the sun was at low levels of sunspots. There weren't any during some of those years. So this plot here, this block plot, is kind of the averages. And in global warming analysis, if you look at this from 1850 to the present, you see that the sun has gotten slightly brighter, more sunspots. Actually, sunspots, you think it's going to be fainter. Sunspots are like measles. They're a symptom of magnetic activity on the sun. The sun is actually brighter when there's more sunspots. So this is quite often used for climate deniers in the sense that the sun, in terms of human, is that the sun was getting brighter slightly during this interval. And I put that up there now because we'll show a little bit later on that isn't here. Because he connected Aurora Borealis, Northern Lights, he connected that with sunspots. The sun is full of spots, it's magnetically active, and it produces the plasma shot out, and it produces these beautiful northern lights that you can't see in this area because of the light pollution. But if you're up in Canada, you see these almost every night. They are very, very strong when the sun is active. This is how it works. Sorry, there's a little bit of physics. The sun, fortunately, we're not that near to the sun. The sun has a flare, and fortunately, here it has a magnetic shielding, and the plasma goes mostly around, but it hits the north and south magnetic poles. When the plasma comes in, it fluoresces the gas up at up at 60, 70 miles, and it produces the lights, the northern lights, or the borealis. That's aurora comes. So if you live in Alaska, aurora up there every night. Here, it has to be a very, very special one for it to be seen at this latitude. This is the plot that actually I wanted to show, because this is one from the Stanford Solar Center, and this is a plot of 1880 to 1990s, showing the bottom one is sunspots and an average part. The top one is temperature change. This is the plot that is used in climate denier studies, except they stop at 1980. You won't see this part here, because what has happened is that from 1990 on, and I actually did this work. I thought the sun, because of that correlation, look at the red curve, look at the bottom curve, I thought the sun was actually one of the drivers of climate change. It was. It produced a maybe 0.2 of a degree Fahrenheit rise, where the actual number is almost 2. The middle one, the blue, is this carbon dioxide. So you see it's tracking carbon dioxide quite well. So the sun has turned down. I put 2015 numbers in there. This will be discussed by Richard Alley in some part this afternoon. But this is what you see here in a climate denier kind of thing. In 1980, you will see the rest of the state. You won't see the sun turning down, which kind of destroys that correlation. So I put that in there, even though it's not Mendel related. Mendel did do sunspots. He never tied them to climate. He did tie them to weather. So what he did is the 8 publications that he made are actually just compilations of temperature, humidity, wind. He used to look. He didn't have an emitter. He looked at smoke coming out of chimneys and flags nearby to get the wind direction. So this is his handwriting, which is very, very neat. You can always tell Mendel's handwriting because he's very careful. And look what he did. At 6 a.m., 2 p.m., and 10 p.m., he entered these numbers. You know, that's why I imagine much why he didn't do night astronomy. What he did, so he wouldn't have any time. So this is the data prior to about 1875, 1878, was done at a hospital nearby. And he just copied the instruments that Dr. Ovchek had and just duplicated them at the monastery, and then carried this on. And this is where most of his publications are. They're kind of boring. You look through these tables of this stuff, and I actually started to analyze it to determine what temperatures he got and things like that. And it's just very tedious, and it's a 20-year record. So most of his publications, every year he published a compilation of tables where he averaged them, and that's what was published. So what he did at this time, he collected the data, he recorded the meteorological, these written records. His first meteorological paper is 1862. Let me mention one thing. He was not known at his time as a geneticist or a hybridizing. He was known as a meteorologist. And he organized the Austrian Meteorological Society in 1865. So this was the thing that he's famous for. The P's was done in 7 or 8 years during this interval, but at his time when he was living, that was not a big deal. He was known in that area as a pretty good meteorologist. So that's what this is from the Mendel Museum. Most of my slides will be. So this is from the book by Jan Mansar, who actually rediscovered his work. And what he's saying here. So the name of the great natural scientist who lived and worked in Bern and connected with genetic discovery. You get down to the bottom here is that the history of the science after his death began forward. Some of the other activities, especially those that feed meteorology, have been wrongfully neglected. And until recently. And Mendel's genuine interest in scientific discipline was probably based on his awareness of weather and plants. Again, his family was a farming. So agriculture was kind of driving him. That was his main thing, to do better there. This is a collage of meteorological instruments. Some of these still exist. And you have barometers, psychrometers, things for measuring pressure. This is an outdoor-indoor thermometer. This is attached to the outside of the building, the north side. And in there, you can barely see it, there's two thermometers. One measures maximum temperature during the day, one measures minimum temperature. This is still there. This is reinstalled because they continued observations in about 2005. They put one of these in again to see if any changes were taking place. That's where these things were published. This blurry thing, which I think Father Ellis took. It's kind of clever as it is in Guinan, you know. That's my own fault. I couldn't get a better picture than that. And who cares? I don't want to read those numbers anyway. This is the Abbey from the air, and there was a study taking place by two people. It's Lichnon and Rozadowski, a close number. What they did is they went back with all that data, converted it into a scale, the Celsius scale, because it wasn't in that. And this is where the observations were made. They had to be made on the north side of the building because you don't want the sun hitting the thermometer. And presently, the instruments are in a regular meteorological setup. And what they did is they analyzed the data from those years and compared it to present. So they have 1850s, 60s, 70s, and then they have 2000. And now this is a plot of climate change from global. This is global climate. Where he lived is 45 degrees north or so. So that's Bruno's measure. That's his measure of the little red star, that little blue star is. And there's the present day. Now what happens is that it looks off. It isn't. This globally average stuff is taking care of the equator. There's a much larger temperature rise at higher latitudes. If you go up into 60, 70 degrees, the temperature change since 1880 is 4 degrees. So this is fits in with the rest of the data, like a place like Paris. You do have to watch out also for called urban effect. Is that the city then was built around, and you have to kind of take that into account. What I want to show you here is that some of the data that he collected is useful historically, although there are about 75 meteorological stations at the same time. The data then seems to fit with the rest of it. So he made good observations. What he did is, also I didn't put Mendel the hydrologist, but this is called Mendel's well, if you ever visit. And what he did here is that he went down here to check the water levels as a function of rainfall, things like that for farmers. So he used that well to go down and see what the water table was. It's amazing I don't know what he had time, I don't know where he had time to think of all these. Now we're going to go to his major contribution to meteorology, which was really not appreciated until the 1980s, 90s. So this is a picture of tornadoes, were scary. They're very rare in Europe. The United States, first of all, holds the record. We are number 1 in tornadoes, so never forget that. America is great now, and it will always be in tornadoes. So we're not trying to make America great. I wish we had less, because we are set up. We are geographically set up for tornadoes. So they were scary things. They thought they were called diablos because they came out of nowhere and they destroyed villages in Europe. And then you think of these poor people immigrating to the U.S. They're going out to Kansas, where you have giant giant tornadoes. And it was a very scary. So this was the devil, Diablo. And they really didn't understand them. They thought they were things from God, they were punishments. And it was kind of Mendel, in that time that Mendel lived. This was kind of the idea that they were hard to figure out. They were kind of punishment from God and things of that sort. So now, this is actually a tornado in Bern 10 years ago, but this isn't Mendel's tornado. I couldn't find any photographs or anything of it, but Mendel gives a description in this book, 18 pages long. This is his famous book they were called Windposten. Windhouse is just always it's the German word for tornado. And so this is what I'm going to talk about next. And that's about the size of the tornado he would have. It's called an F0, which is scale 0. Winds about 70, 80 miles an hour. Doesn't do a lot of damage, but does some. The ones we get in the Midwest are 5, which are winds of 200, 300 miles an hour, which wipe out whole towns. So what I want to do now is that this is where Mendel, this is, I think, his room, where they had a hard time. The bottom plate, I think the second window, wasn't positive about that. But this is the 1870 picture, or 1850 picture, so the room is in there. I hope these trees aren't here, because he's viewing the tornado from his room. And so I guess the trees maybe aren't there. Maybe they were planted later. So this is Mendel, this is the book, Die Windhoste, from the 13th of October. In that time it was German, so Wern, it became, when it was Czech, it changed to Bruna, and so this is relaxed, this from 1871. So what you have here is that I started to write all this out, and I decided, it wasn't until 1970, Gregor. Alfred Gregor is very famous for continental drift. He's the one that promoted the fact that our continents move around. He also had a paper on tornadoes, Windhoste. Never mentioned Mendel. Wasn't in there at all, whether he was aware of it. This is one of the learning things, is that when you publish papers, the younger people in the audience, publish in high-impact papers. the Moravian science. So they were either neglected or overlooked, maybe bad and not included. You really didn't get recognized, and it wasn't until in the 1990s where people looked at this paper and decided that it was a breakthrough science. So what you want to look at here is that he's usually regarded as the beginnings of the scientific research of tornadoes. This is now. This is like 1990s. And the meteorologist's work is well known during his time, and you have the opposite. In contrast, the work on peas was not appreciated during his time. It was discovered and appreciated 30, 40 years later. So that's the figure here. So there are, the book that you have here, there are about 200 copies of this around. We could locate, most of them were sent to small universities and institutes, and we were lucky to have this at Villanova in the Mendel collection. So afterwards, if you want to know, you can't touch it, but you can, okay. So this is part of the book. Fortunately, I had to start translating that in German. It's old German, which I did have, but I found an English translation. So that's the beginning of it, and then this is what it is in English. So I'll just step back in order to read the whole thing. So this is how it begins on the 13th. He's giving a talk 1 month later at the Austrian Society, and he had the opportunity to observe a very rare event. Well, a tornado went over his house, went right over it. And so and it came from behind. From his room faced east. This tornado came from the west. So he talks about the malicious, it's sort of a nice language, he's sort of, I suppose. More impressive and stormy drama appears from a certain distance, the more dangerous and unpleasant it is for all who experience the immediate contact with it. And then he goes on the date and how lucky he was to survive. Then I skipped along, and that day, it happened around 2 p.m. It suddenly darkened, which happens during tornadoes. Twilight, kind of eerie look. Has anybody had a tornado? Oh, you guys. How did you know?
Very scared.
And you survived.
Kansas.
And the noise, he talks about the noise, definite noise of a tornado, right? Is that what? Yeah. Where did you get it?
Kansas State University.
Okay. Yeah. So I had a tornado entry. Yeah. And now it's tornado tourism. Tornadoes.
Crazy.
Yeah. Just 2 days ago, unfortunately, 2 people lost their lives. They go right into these. And we make some money on that. Kansas, Nebraska. Kansas is, well, that's where most of them are. It's tornado. So it goes on, and he gets into the building shook, and I took the data that and I'm going to put it all here because it's in the book. I took the data that he had and tried to translate it into a model. how the winds, the damage, you're able to translate that into the speeds and what kind of tornado it was. Tornadoes are listed on a Fujita scale, enhanced Fujita scale. 0 is the minimal, and 5 is the worst. So what he did is that if you go through the book, then it was this tornado. You go through the book, he talks about, first of all, it was hour-shaped. So there's different types of ropes, there's all kinds of things. So the one that he mentioned had an hour-shaped look. He estimates the rotation because he saw debris blowing, and very unusually, it's an anticyclonic. Most tornadoes go cyclone. They go counterclockwise. This one had a clockwise rotation, which he noted. So he knew that. And he gives where he started. It started at western Florida City and Kennedy Beach. I wish the Czech language had some vowels. Am I close to that beach? Andre, where is that? How do you pronounce that?
What?
The Kemeni...
Kamení vrch. Stonehill.
Oh, Stonehill. Okay, I knew that.
Sure.
So he gives the whole where it comes, the streets, and Steelwood is a big palace that's up there, and this is in the report. So you go through. What I did here is that there's the Czech Republic, there's Bern, where's Bern? Show that. There it is, and that's the castle, and then here it's going to be a monastery. So I just want to zoom in, because what we did now is got a map of modern Bern, which I tried an older one, and I couldn't figure out the exact dates. So the path, the path is coming up. So we took what he wrote, and these little things, and this is the path of the tornado. That's the western side of the city. Tornadoes usually go northwest. They go from southwest to northwest, which is kind of this is doing. In here it gets confusing. There's Mendel's, the monastery. Spielberg Hill is that castle. There's a street there which we found. And then it seems to go in the direction of east, and it says it vanishes behind a church. The church is over here, and then it went north. It's a little bit odd, but that's what we were figuring out. And it lasted, the length of that is about 7 kilometers. This is then the properties of the tornado. So ground speed, he did the ground speed because he timed it, how many seconds it took to go over. And he said we get 20, 22 miles. That's about what they go. That's not unusual. The direction is north, northeast, north, northeast as it changed. About 2 o'clock. It looks like there was a place at 1:58, but we'll put 2 there. They broke 1,000 windows in the monastery, 1,300 windows panes in the church. So you're able to actually, that gives you some numbers on how strong the winds were. The speed, he got the speed, or I got the speed actually, looking at the wind, the damage that it made, what it did. It did knock down too many trees. It knocked windows out. It took some shingles off his roof. So that would be an F0. It's a Virginia scale that weights these. So it was anti-cyclonic. 1 out of 10 hurricanes. 1 out of 10 tornadoes is clockwise. Most of them are counterclockwise. The width of the funnel he looked at and measured, it was like somewhere in the order of 10 to 14 feet, and that's what you get with a minimal tornado. And the damage is sort of what he could look. What he did is, all the stuff is in Denver. He went out the next day, interviewed people in the fields that were scared to death of it. So he was able actually to go to where he looked for the damage, traced its path. Because this is behind him. It was coming in from behind the west, which really faces east. So all the information collected was done by interviewing people who go into the cities to look for the damage path. Piece that together. So it's a pretty good scientific investigation, and actually very easy reading because it's not, these things don't appear in there, you have to kind of weed them out. So I wanted to give you some idea of this Fujita scale, modified Fujita scale. So it's somewhere in this realm. Minor damage, good damage. It was not these devastating ones here, or catastrophic, where everything would have been killed. Because it would have turned down the building. So so we think it was a 1, a 0, maybe going to a 1, So moves are taken off on a 2, on a 1, and 2. So we think it was an F0 because of the damage, the lack of damage, I guess. How they form, he was actually, at the end of the paper, he talks about how they form. Now, of course, this is modern. He remarks that it was a warm day, and there was in his meteorological records, a cold front was approaching. And that's kind of what you get with tornadoes. So what happens with a tornado, a cold front comes in, you have warm, moist air full of moisture, it pushes the air up, the air condenses into clouds, that releases what's called latent heat that generates it, and then as it rolls in, the sun is coming in, and it rolls the air, you get dust. You get gusty air, and that goes up and eventually straightens out and gives you the funnel. So the top and the bottom show that. To give you what he mentions at the end of the paper, he talks about how they form. And it is a clash of cold air and warm air. And I'm now using the U.S. because this is why the U.S. leads the country, leads the world in tornadoes, is because down here, the Gulf of Mexico is warm water with warm air over it. And we have air coming in from Canada. So you get that tornado alley, which includes Kansas, is right in the middle of there. So it's usually a cold front coming in, an occlusion, and it comes in and you get the tornadoes filling in. So we can now see these kind of things. At his time, he had no weather match. Fronts didn't exist. Weather was primitive. He knew a cold front was coming in, or cold air was coming in, and he related that to the storm. Thunderstorms are produced by that kind of mechanism. So that was kind of nice, too. In the last 2 pages, he talks about that. And we have, for America, since 75 tornadoes occur in the U.S. They're rare in Central Europe because it doesn't have the same setup. It's far away from a source of warm, moist air. Mediterranean is too far away, there's mountains. But you do get tornadoes. They're rare, but they're there. And they get more frequent because as people have video cameras and all, you find that they're increasing in number, but you're not really sure whether that's really an increase or just that they're being spotted more often. So what I'm going to do now is show you in a minute a view from the National Geographic. The cows did not get killed? Okay, so... My students found really bad when they had cows being swept up. So I didn't want to. So he says, there's a lot of curse words, so I got those for them. So these are coming from, oh my God. Oh, what the hell did you go? Oh, no, we have to. So this is like a 4. This is nowhere near what, and Europe doesn't affect these because it doesn't have the conditions much what happens here. The person is saying, Mom, it's our house. And you're going to see.
The house is coming apart.
There's that house. They're out of it. Nobody killed the bees.
Oh my God!
So tornado destruction is like carpet bombing in World War II. There's nothing left. It's a residual bomb. What's happening there? Oh, that's just hitting another person and knock out something. Oh, that's nice. The little one joining the left. All that bottom is dust. Why it's dark is because dust is getting something. Yeah, I wanted to keep that minimal. If you go on YouTube, you can find any number of these things. It's also, this tornado is pretty famous. The original tornado, strangely enough, even though Bern doesn't get that many tornadoes, the team there, the soccer team, are called the Tornado Brune. And these are, I think, high school kids, but I noticed up here, this is something you don't really see in the U.S. A bottle of champagne. It's just anticipating a win. So in summary, amazing person. In addition to carrying out all of his clerical religious duties, he was able to conduct a remarkable amount of independent research, most famous for genetics, discovery of laws of heredity, and then the first scientifically based description of a tornado, which wasn't done until 50 years later, and it wasn't recognized until much later. I had one last thing, is that I'm throwing in this one. Father Jenkins was the founder of our department. He was also a polymath. Maybe it's in the Augustinian tradition. I'm not sure. So I would put this in. He was born in 1906 and died in 1991. He was ordained in 1931. He was a chemistry instructor here starting in 1935 while working on his PhD. He got his PhD in 1939. And it was rumored, because working with synthetic rubber, it was rumored that it was a sabotage, that the Germans, he doesn't believe it. There was a fire in his lab, and the rumor of the students was that there was a German sabotage because of the approaching World War II. He was amused by that. He also, in 1950, became interested in astronomy. He was always interested in astronomy. In fact, see this picture? That's Halley's Comet. And he was always interested. He claimed that his mother showed at 5 years old, she pointed him up and showed him Halley's Comet. He wanted to live to see Halley's Comet, and he did. Halley's Comet returned in 1986. So that was his goal. And then he said, what are you going to do now? I'm waiting for the transit of Venus. He never made it there, but he did get to Halley's Comet. We made a big deal in terms of having him see it. He established the first astronomy program here. He built an observatory, which is still here. It's on top of Tallentine, where he got a silo and carved it out and made a small observatory. Built the telescope by hand. He grounded the Mira at the Franklin Institute. And so he established the astronomy department. I have the wrong date. In 1961, I forgot to correct that. And that's what we have now. So we're part of that astronomy. It's now called, it goes to different names. It's now called Astrophysics and Planetary Science. And he also was very interested in genealogies. He published, and I used to listen to him talk about this, which was kind of boring. You know, I'm in 1725. And it was the Ark of the Dove, and it was Catholic families. I knew more about Catholic families in Maryland than I wanted to. And he was, his aunt was Sergeant Schreier. His aunt lived to be 105. I said, you had an aunt? He was like 80 then. Yeah, I have an aunt. I was going down to visit her, and she lived in Maryland. And it turned out to be Sergeant Schreiber's mother, which related to his brother, who looks like Father Jenkins, but with really long hair, white long hair, won an Oscar, an Academy Award for the set in All the President's Men. So I met George. George actually gave money to establish a fund, scholarship fund, which is $10,000, $11,000 that we give out to our best astronomy majors. So I wanted to work him in. One of the things that how I got my job, I didn't put that in there as a hired that guy in. But I took some courses. I took German with him. So he taught German. I took astronomy. And one of the ways I got my job is that as a kid, I raised tropical fish. I was like, my mother hated it. The tanks leaked and they're catastrophic. She was very glad when the bowl were tropical. Then she killed me. So Father had tropical fish when I arrived. So I kind of knew how to, and they weren't doing well. And he would sit there and watch them and have tanks. And at the end, in my expertise in tropical fish, at the end he had 12 tanks and 4,000 fish. And we used to sit there and watch them have babies and have a drink while this was going on. I tell people that, you know, that's how I got hired, is that my knowledge of astronomy takes care of this tropical fish. And my mother, I told my mother, she said, well, I don't know, it's not worth it. You know, she was, I tortured her with having this fish. So I want to thank you, and I have a little joke on Ronald Mendel getting tired of peace. I left 5 minutes for questions because he starts. If you have any questions in here, I left an hour for it. 5 minutes for finish.
So his scientific observations were not part of his community duties. These were all privately conducted on his own.
Yes.
And another meteorological question. are thunderstorms as big in Europe as tornadoes. So they kind of go together.
They kind of go together, but not all thunderstorms develop into tornadoes. So the conditions in the U.S. are such, having the Gulf of Mexico, warm, moist air, cold air from Canada is why the United States has so many tornadoes. Europe has them. The Czech Republic maybe has 2 or 3 a year. You can go back and look. I was going to add that in, and I decided that was kind of boring, but so they're not that rare. I really, the strange thing is I feel bad for the immigrants who never saw a tornado, and then they went west. You know, it must have been really scary for them because they just knocked down everything. So yeah, so they're pretty rare. Because China has the China Sea and it's warm, they get some, but we're far ahead of anybody else. Never. The only continent that doesn't have tornadoes is Antarctica. Surprise.
Yeah.
Okay, this was wonderful, thank you, and especially your delivery. What's the difference between a cyclone and a tornado? And one comment, last week I heard the new Cardinal of Manila speak about climate change in Manila, that they are hit by cyclones a great deal, but generally it was always 70 to 80 miles an hour, 100 miles an hour, but now it has escalated. They're much higher, 200 to 300 miles an hour.
Tropical cyclones are hurricanes.
And hitting islands that they never hit before, and the buildings are not built to withstand those kinds of winds.
Yeah, it's not sure what the jury's out on. To answer the question, cyclone is when you have cyclonic flow in the northern hemisphere. It's counterclockwise. The air is coming in. And a tropical cyclone is, we call them hurricanes. In the Philippines, they're called typhoons and cyclones. They get really big ones. And there's a scale for them too. And they're wondering whether, it goes up to a 5, they're wondering whether to make the scale go to 6 because they're super cyclones. Things with 200, 250 mile an hour winds. And global warming kind of predictions, they come from the warm water and the water temperature's gone up. So there might be more of them or bigger ones. I'm not sure. You don't have enough data baseline to see if there's really a correlation between super hurricanes, frequency of hurricanes, and global warming. There should be, but I have no, people in that field don't rating for more data. Yeah, Philippines gets hit. They're a poor country. The housing is, flimsy, and they're in a path of major path of tornadoes. In the U.S., it's the southern Gulf Coast, like New Orleans. New Orleans is below sea level. It's in the path of tornadoes and hurricanes. They get both. Now, Philippines doesn't get tornadoes, so but they do get these huge hurricanes. Yeah, so that's still being investigated. The models predict, and I guess, are you going to talk about that?
Not much about it, but he's completely accurate.
Thank you.
The maximum strength of the biggest storms goes up with warming.
Yeah.
But the number may go down for other reasons, so you wait longer and then you get way down.
Any others? Any other questions?
Yeah. Could you say anything about Mendel and the urban heat island?
Yes. It's a paper I suggested showed. They tried to correlate that with measurements made downtown and measurements made then. There might be a 0.2 degree difference between the two, so you can correct that. The study was made comparing it to Prague, where their meteorological equipment isn't downtown Prague, so they are slightly lower than that. So that's what the heat island is that, as I alluded to, is that a lot of these old observatories or meteorological stations were in the middle of cities, and the cities expanded, and then cities are hotter because of asphalt and trapping the hotter air, so you have to correct for urban heat island. Like Philadelphia is usually 2 degrees warmer than us. We're in the suburbs because of this effect. So they have to correct for, in dealing with historical data, you have to correct for this. And it's done by having you have a telescope. You have equipment in the middle city and you move it out and you compare the two and you get the big range.
And Mendel figured it out.
Mendel knew about that. I don't know if he figured it out, but he knew about it. He was aware of it. He was aware of a lot.
I don't know what kind of leg he had, the poor guy. At 6 a.m. going in, from 2 o'clock to 10, Then he was up again and he was doing peas and then water, checking the well and bees, He had a very busy life and he got a lot done. Okay, I'll stop now.